Okay, we have one more applied problem that I want to look at, and this is a situation where we're given a formula for the number of diagonals for a polygon within sides. To understand what's going on here, if you have a rectangle, right, that rectangle has two diagonals. Now the rectangle has four sides, so if you were to put n equals 4 into the formula, you'd have 1/2 of 4, which is 2. 4 minus 3 is 1, 2 times 1. So a rectangle or a square should have two diagonals, and you can see from the picture that it does. So this formula, it turns out there's actually a formula that relates the number of sides, the number of diagonals, if you know how many sides it has. If you know how many sides, then you know how many diagonals you can make. And so our problem says, hey, is there a polygon that has 27 diagonals? And if so, how many sides would that polygon have? So we know that we have 27 diagonals. So I'm going to put 27 in for D. And so that would be equal to 1/2 n times n minus 3. So we have an equation here, but the darn equation has a fraction in it. And so when I run into equations, fractions, I want to get rid of them. So I'm going to do that by multiplying through by my common denominator. In this case I have only the one fraction, so I'm going to multiply both sides by 2. Now be careful here. You multiply each term. Terms are things that are separated by an equal sign or a plus and a minus sign. That 1/2 n and n minus 3 is one term. It's just a big product. So the 2 is only going to be multiplied times just that whole thing once, not 3 different times. Now remember, when you're multiplying, that you can multiply any two things. So I can multiply the 2 times the n, or the 2 times the n minus 3, but it's a heck of a lot easier if I just multiply by the 2, the 1/2. And so simplifying, we have the equation 54 equals n times n minus 3. I ask you to take a moment now and pause the video and try to go ahead and solve that equation and then catch up with us. So here I've performed a couple steps at once. I multiplied n times n minus 3 to get n squared minus 3n. And while I was at it, I went ahead and subtracted the 54 over. Okay, we then factor that equation. And that leads us to two equations. N minus 9 is 0, which would mean n has to be 9. Or n plus 6 is 0, which would mean n would have to be negative 6. Now again, keep in mind the context of the problem. We need to know how many sides the polygon would have. Well, just like I've never had a measurement, something was a negative inch long, how can you have a negative number of sides? And the answer is we can't. So that answer doesn't make sense, meaning that we must have 9 sides. You might want to challenge yourself and draw a 9-sided polygon, and then start forming the diagonals and count them. See if you do get 27 diagonals.